still you need. Okay, so let me go for open the pandas package. Documentation, right? So we seen that these things, right? Like, what kind of data we have it. User guide. So series series type of data, and creating the data frame and accessing the some specific columns. Hmm? This is data frame. So structured record array, and we if we have some kind of list that we can converting into the data frame with help of the data frame function. Okay, we have some kind of tuple data. So this is the A and B. This is okay, this is the A and B, it's a key, and this entire thing, it could be it could be value. Okay, so you already know that the dictionary data type, right? Okay, so you can creating the data frames. A lot of things we have it, guys. Okay, and when you're working on some basic functionalities, tail method, and tail will help to access the last things. And if you want to access the, if I'm using the head, we can able to access the first attributes, right? Okay, or first elements. So we can go through it actually. So even you cannot figure out so these things. And what I would like to tell you before we start, I mean, this pandas and numpy, you can concentrate on it. And let's go for the matplotlib as well. Okay, this matplotlib also it will be playing a important role in a data science. Let's go for understanding the matplotlib library. Okay, so get started. So for example, if the matplotlib which is not available in your local computer, then what we will do, we can use either this command, either we can use this command. Okay, if you are using the conda, then we can open the conda environment, or else a terminal, and we can execute this particular command. Or else if you are using the standard Python, then we can use the pip install matplotlib. Okay, this is the way we can able to install the package, the matplotlib. The next one is, if you want to be plot anything, so you already know that, right? NumPy is a numerical Python. It will do a lot of functionalities. So you just look this particular thing. This is the matplotlib which is having the pyplot. This is the pyplot package. It will plotting the lot of graphs as well. Okay, so this is the thing we are going to importing with this particular step. So the numpy also we should go for implement. The reason is that we should create the some x data, and we should go for creating the y data. Okay, we have some kind of elements in between the 0 to 2 into 2 into pi, 2 into pi in the sense 360, 0 to 360 degrees, right? 0 to 360 degrees, and we are taking the 200 elements equally splitted line space, which is equally splitted in between 0 to 2 into pi. Okay, in between 2 to 5, in between 2 to 0 to 2 into pi. Okay, you're creating the 200 elements. So with this particular 200 elements, we are assigning the sign function. When you're assigning the sign function, for each and every value of these elements, we are finding the sign value, or we are finding the sign value that I'm holding into the y variable. Okay, and I'm creating the one particular plot. So that the name, we are creating one particular plot with help of the subplots. By default, it can be creating only one plot if I'm not giving anything. But if you want to create the two plots, then we can subplots of 2 comma 2 we can provide it. Okay, so this is the way it can be returns the two things. One is the figure, one is the AX. X in the sense axis. So this means this is the graph attribute. Okay, AX is nothing but it's a graph attribute. So this is the graph attribute. We are plotting the X value and we are plotting the Y value, and we are going to be showing the plot as. You're going to be showing this particular plot. Clear? So if you're not understood this one, please let me know, guys, because of you already aware of it. NumPy, so you know the linspace what exactly which is doing, and so sine function what it is doing also you already know it. Sine function, it is just calculating the sine value of each and every element.
So Anjan, it's just a Python function that's used to do plotting.
It's not Python function, it's a Matplotlib module. It's not
Okay.
Python function. Python functions are means what? We are not using any
Okay.
library.
Okay.
Okay.
Package basically. Yeah, it's a
Package.
Python package to.
Matplotlib for visualization package.
Okay. So when you have something like a Databricks, if you're using Databricks, it can automatically show charts, right?
Yes, same like that only. Even
Okay.
Excel also, even R also, even SPSS and Tableau, Power BI, we have other visualization tools, right? Reporting tools, right? There we can able to create some kind of graphs, right? The same thing we can achieve with help of the, okay, a Python programming language. Okay, the Python which is providing the package, which is Matplotlib. With help of that one, we can do this thing. So let's go for understanding the Matplotlib. So here I just try to be understand. I'm not executing this one. See, when you're doing this operation, first we should implement the or we should import the required packages. So if you want to plot anything, we should import the Matplotlib. And when you're working with the data science, make sure that you should have the NumPy library. Okay. After that one, what is the linspace? Do you aware of it? I already explained, right? What exactly the linspace is doing. So the linspace which is creating the elements equally splitting in between some range of in between these two things, 200 elements which is generating, and this all elements having the equally splitted. The difference between any two successive, it could be the same for it. Okay. Now this is the X. We are going to be applying the sine function for each value. What is the value of the sine 0? Sine 0, 0 only, right? Sine 0 is 0 or not? Yes, sine 0 is 0. What could be the sine 90?
1.
1, right? And so somewhere else it could be the 1. Okay, this is also 0 only. Okay, negative values, positive value. This is the sine values for each and everything. Okay, so once if we have the sine x data and y data, then directly we can plot as well. Okay, plt dot, without those things also we can plot it. Plt dot plot, and we just provide the x comma y, which is providing it, right? If I want to show that graph, then we can use the plot to dot show method. We can use it. So that subplot, why? What is the use of this particular subplot? For example, I want to be go for creating the multiple graphs. Multiple graphs, 2 comma 2 in the sense. So we are going to be creating the 2 rows and 2 columns of graph. This is one sub block, this is one block, and this is one block. I mean, this is one graph, this is one graph, this is one graph, this is one graph, right? Dashboard. If you want to create the multiple dash, if you want to create the one dashboard in a single, okay, then we can go for this particular function subplot. Okay, as of now, you're going to be displaying only one function, right? So that we don't need to use the subplot. Any question? So x is x-axis and this is y-axis. Okay, so 0 to 6, this is your x data and this is the y data. So y data is the sine values, right? So the maximum sine, it can be 1. The less small sine value, it's a -1. So the range, it could be -1 to +1 only sine values. Okay, so usually it can be sine 0, it could be the 0, but sine 90, it could be the 1, right? And sine 180, it could be the 0 or not. Okay, so that's why we can creating the each and everything. Okay, we can create the plots in such a way. We just plotted only one graph, right? So next, so this is first graph. Okay, this is get started examples or tutorials, reference, user guide. Let's go for user guide. Introduction, intermediate. Let's go for, so here we have x data and y data. So subplots, here we have x data and here we have the y data, right? So here directly we are giving the x data and y data. So corresponding one, corresponding x, what could be the value of y? It 1, right? So that which is started with here. Okay, what could be the value of x and what could be the value of y? So when the x is 2, then what could be the value of y? It's a 4, right? So that it's a peak value. Okay, and when x is 3, then what could be the value of y? It could be the 2, right? So that it was less peak. Now the value of 4, then the corresponding value of y is 3. So that the line is here. So with help of the plot, we can plot the line plot. Is it clear? So why we are getting this result, you understood, right? So here we have a plot function. It can receiving the x data and y data. And so it is explaining the axis, what exactly axis is doing. And for example, here we are creating the one matrix, and this is my matrix 1 comma 2, and we are creating the array, and this is the matrix we are converting as the array. So here we have some b values, and when you are using the seed is nothing but seed generation. So when you are when you are using the seed which is generating the constant values, even we can run 100 times, 1,000 times. Okay, so the values could not be changed for anyone. It can be the same only when you're using the seed function. Okay, so here we have a data is a and c and d is my column, and this is my data, and it's a 50 values are there, and we are generating the 50 elements 0 to 50, and randomly we are generating the 50 elements in between 50, and random in the sense randomly we are generating the 50 elements. Okay, whether it is integer float, it doesn't matter. Okay, this is the way we are generating the three different elements. One is the 0 to 50, one is the in between 0 to 50, randomly 50 elements, we don't know what could be the values it is, and random 50 elements we are generating. So random 50 in the sense it can be anything, right? So this is the values we are taking into the data variable, and now a c d is done, right? And b and d, so here the b we are creating, we are updating the b value, okay, with the addition of the a and with multiplication of okay, and this function, then we are updating the b value, I mean we are creating the new b value. Okay, so then after you are updating the d, and this is the a and b and c columns, we are plotting the same graph. Okay, we creating one particular sub block, and the figure size is it's a 5 comma 2.7. That means the length it could be the 5 and the width it could be the 2.7. Okay, and the layout is constrained. So this is the way we are just created on particular graph over here, and now we are plotted the scatter plot. Scatter means circles. The circles are a and b, and the color c means it's a color. Okay, it's a c is my, okay, c data we are plotting over here, and this means d data, d column. So a b c d are my this, you're taking this you're taking these particular columns. Okay, this entire data you're giving as input for this particular data, then which is plotting on different circles, right? Different colors we are getting or not? Orange, yellow color and blue color. Okay, and little bit of green colors we are getting or not? So coding also, even coloring also we can mention it with help of this c. So here we are plotting the three different lines. So plot is the function, it's for line plot. This is for line plot, this is for line plot. Here x is my x variable, here y it was changing, y for first plot it is x versus x, for second plot it's x power of 2, for third plot it's x power of 3. Here label is labeling you're mentioning, the label is linear. That means here your legend you're mentioning, right? This is the legend. Within this particular legend, so first could be the label is linear, second one is quadratic, and third one is a cubic. So this is the legend was created over here. Okay, and automatically the coloring it can be mentioned, but you can specify whatever the color you want it, okay, with help of the color attribute. So within the same graph we can able to plot the multiple lines, okay. Now this one and this one is almost same, but you're taking the this one and this one, it could be the same, right? Now making the helper function, so you already know that what exactly help function is doing. And so here we are creating your own function, but here we are giving the data 1 and data 2 and underscore underscore param underscore dict, in the sense we are unpacking this data, okay. And so we are giving this particular data to data 1 and data 2, so which automatically creating the plot for us, okay. This is the way we can create our own functions as well. And for example, you are creating the random elements from 4 to 100, and this random data we are holding it to the data 1, data 2, data 3 and data 4, okay. So we are plotting we can plot data 1 versus data 2 and data 3 versus data 4, okay. So here I am creating the my own function, this is my own function. So when I'm creating this one function, here I created the 1 comma 2, right? 1 comma 2 means what? So in a one line we have the two rows are there. That means two graphs. So for first graph or first row of the first graph is ax1, first row of the second one is ax2. This is the way, this is the way we can able to go for or this is the way we can able to go for giving the graph names. This is the graph name 1, this is graph name 2, that means this is x1, this is x2. This is xe1 for line plot, data 1 versus data 2, and data 3 versus data 4, this is our second one, okay. But here you mentioned the marker is x and here the marker is o. That means this is a param underscore dictionary. What exactly it is doing, we are mentioning the what style, what is the points we should mention it. The points are here cross mark, x mark, okay. Here the marker is o means circle. That's the reason here the points are circle, here the points are x format. Is it clear? This is the way we can able to create our own functions and we can call it. So we can mentioning the styling as well. So styling in the sense what could be the lines we should mention it, and the legends and the line width, how much you can mention it, and what color I should use it. Everything you can mention with help of this to these particular attributes. Okay. So here the colors scatter data 1 and data 2. S is a 50. 50 means it's a size, and face color is a C0. C0 in the sense it's a circle with a line. The line it could be the black color, but internal color could be the different one. Okay. Edge color is K. Edge color is K in the sense it's a black color. Okay. This is the way we can create the scatter with edge color is different color and face color is different color. C0, right? C0 in the sense it's a color is some little bit blue and edge color is some black color. So here we can creating the different graphs in different shapes. So here we have the three plots we are within the same graph we are plotting, okay. So ax is nothing but it's a single graph. Within the single graph we are displaying the four different data elements: data 1, data 2, data 3. Data is a circle, data d is nothing but diamond, v is in the sense v shape, and s in the sense it's a circle, sorry, square. S means square, V means triangle, and D means diamond, O means circle. So this is the way the shape also we can mention it. So label is can be help you to create the legend. So when I'm using the legend function, this is the box can be created and it is giving what exactly meaning of it. Okay. This is the way the Matplotlib will help you to create some kind of functions. I mean to create to plot some kind of graphs. So this is the histogram. So if you want to plot the histograms, then we can x label and y label, right? So here hist function is there. So hist is the function, it can help you to plot the distribution graphs, density functions. So here I have the x, this is my x way. Oh shit. So I have the x data, okay, the here mu and sigma, that this is my mean and this is my standard deviation. With help of the mean and standard deviation, and I created some random data. So this is my normal distribution, so that this is a graph which is something like parabola, okay, I mean curve. So here I created one particular one graph, and the graph name, this is the layout is constraint. So here what I did here, I'm using the ist function. When I'm using the ist function, which is plotting histogram. So histogram in the sense, it's a distribution graph, density and density graph. So when you are mentioning the density, that means each and every element how many times which is repeated. So that many times that could be the value of y. Okay, usually the probability it could be 0 to 1 only. Maximum is 1, minimum is 0. So when you're combining this all, the probability it could be the 1. So this is the way you can able to plot the histograms. And so this is the line plot, right? So plot will be a line plot. So even this is also plot function only. This is the time series, right? Even time series also will be similar to the line plot only. Okay, plot function only. And even this is also plot function. Even this is the thing we are calling it's a bar graph. Okay, so if you want to display the bars, okay, in your data, then we can use the bar function. And so legend and color mapped. So if you want to color backend and the front end, if you want to make it some kind of colors, we can use p color mesh, we can use it. So guys, anyway, if you want to create the data, I mean dashboard, okay, left, low left and right, we have right one particular graph, and upper left you want to create one graph, and lower left you want to create one more graph. For that one we can use the subplot underscore mosaic, and you can mention that what could be you want to make it. Okay, right, right, left and right. So left, upper left and low, right actually, low left and right. So which means that we are having the right will be the two, right? So that means we are having only one graph at right. Okay, but in left side we have up and low, we have it, right? So that means we have the two graphs we created over here. Okay, so he axt, oh shit, it is going to somewhere else. Okay, axt is nothing but your axis. That means each and every graph name. So if you want to access the up left, then we can use the axt up left. Set title is up left, so you can able to mention the what could be the title of it. As of now you're not plotted anything, we can plot whatever you wanted with help of the axt square brackets up left and axt low left, and we can plot whatever you wanted. So this is the way you can create the dashboards as you like it. How many graphs you want to make it in one single plot, then we can do it our own way, clear, within a 5 to 6 lines of program. So these things which can help you guys. And color normalization, okay, more reading. Okay, so we have a lot of examples are there. You can go through this one and we can practice it. This is line plot. For example, I want to plot it bar plot, but each and everything I want to make it some different color. Okay, here we can creating the ax plot subplot. That means we are going to be creating only one graph, and this is the name for that particular graph. And if you want to do anything, we can use this particular name only. Okay, and here we have the four type of fruits are there, and apple will be the 40, and blueberry is 100, and cherry is the 30, and orange is 55. This is the count of each and every fruit. Okay, and for each and every fruit I would like to mention the color. So apple, it could be the red color, and blueberry it could be the blue, and cherry it could be the red, and orange it could be no uh, orange could be the orange color only. Okay, so this is the way I want to be make it some kind of bar label colorings. Okay, and tab colon read red in the sense, so you're making this one bar color actually. So this is the label you created. For this label you're going to be creating the each and every color over here. Okay, see here we are giving the fruit names and count we are giving, and label we have to provide the bar labels. That means this is the colors you should provide it, and for colors we have to provide this particular list over here. Okay, so I mean this is not a list, this is your this is not a dictionary which is a list only. This is the list which is you providing for the color. Then each and everything you are making some different color for each thing. This is the way we can creating the bar graphs with the different things with the different colors. Okay, so this is the way we can creating the bar color bars with colors. Okay, within the same bar graph we can creating, see here, 20 and 25, here 30, 35 and 32, and score by group of gender. So here, if you want to make it, if you want to make the bar graph single bar graph, I want to make it the two things. Okay, for that one we can use this particular function. Which function we should use it? We can use the bar only. And so here we have the importing the libraries, and we have the men data, we have it, and we have the women data. Okay, and this is your men standard, and this could be the women standard, we have it. Now we are arranging the some kind of data indexing. This is your index locations, each and everything. This is the width of each and every bar graph. Okay, so fine, we have the two bar graphs we plotted, right? So this is index, and we are giving the men data and width, and men's. So we are giving some kind of standard deviation, and the label we are mentioning the men. Same way we are plotted the bar graph, and these two bar graphs we are plotted in the same graph, right? Okay, so in the line, H line is 0, a color gray. So index, we are creating the two indexes. Index is, first index is gray color, and second automatically it can be orange color. So anyway, this is the way within the same thing we can create the, within the same bar graph we can create the two things, or else horizontal bar graph we can create the horizontal bar graphs with help of the this particular function. So see guys, this is a code we can copy, we can modify as you like it. It's up to your choice. Okay, you don't think about the code and everything, you just go for this particular standard documentation, and you will be getting the lot of resources over here. We just copy it, and we can manipulate your data, and we will get the each and everything output. Clear? This is just practicing things, and we have a lot of examples are there, and it's not, no, whenever you pre, we can go ahead actually. So this all things we require. Okay, this is the pie chart. So if you want to be pie chart, if you want to create the pie chart, we can go ahead with the pie function for each and everything which is creating the, which we have functionalities, and we can use it. Okay, this is for histograms. This is histogram with the different features. This is exonominal, using histogram to plot cumulative distribution. This is for cumulative distribution. Cumulative, what is mean that cumulative and everything, it depends upon again statistics only. So I would like to give you some tasks for you all, and so go for this particular Matplotlib package and go for examples and practice same things in your computer. Okay, and try to be modify some data, and we can execute it. So Matplotlib and pandas and numpy, this is the three packages you must know it actually. Okay, must know in the sense we don't need to remember all things, you should know how we should use it in effective way, that you should aware of it. Clear guys? Is it clear?
Yep,
Um,
clear.
So
I'm
nothing.
sorry. Can you? Is it possible? Can you show us like a kind of a example or a project that goes through NumPy and
Of
uses
course,
pandas
then
NumPy and then
upcoming sessions, we are going to be using this only. Okay, even if I
okay,
directly start the project with help of this one, how should I understand? So that's, I'm just giving some intro. So that's what,
okay,
just go and look, just open it. It's something like documentation is already available in the free of, right, in a document, right? So just
right,
go and look some functions, and don't need to buy
okay,
hard these things. And we are definitely use, you can understand in a programs everything. Okay, when I started data processing, that definitely I can explain you. Okay, we are going to
okay,
be using the
sure,
same thing only. If without explanation this thing, if I directly start the data processing project, so you might be thinking why I'm using those things, right? Okay, so that's what
right,
we have, resources here, and we just go through these resources, and we can practice it. Okay,
sure,
see
no,
guys, tomorrow we have a we don't have any session, I already told you, right? And Tuesday and Thursday I'm not taking the session. For that one, for that compensation, I would like to make it weekends and Saturday and Sunday with the same time. And what you should do tomorrow, at least we can spend some time and go to the numpy package library documentation, go for the pandas documentation library, just go and look and read it, just go and scroll up what exactly that one, don't need to practice it. Okay, and even Matplotlib also, just open, and each and every example we just open, and try to be understood what exactly happening here. Okay, and if you want to execute it, we can execute it, you won't get any kind of error, you will be getting the same graph as well. Okay, Even you can copy this one and we can execute on your okay here, and you'll be getting the same thing. Nothing, you won't get any kind of error first of all. But that's what, so that we just open that one and try to be, it's a plot show because of you're not giving the parenthesis, right? So you're getting the same thing or not? Yep. So open that one and try to be go for look for the each and every example and what happened, try to be observe yourself. Okay. I don't want to spend some time because of I don't know, I'm getting a lot of pain from my neck as well from the morning onwards, and tomorrow we don't have any session. I hope we are going to be utilize this time for understanding the NumPy, pandas and library, pandas and Matplotlib. Okay. So guys, whenever you have a doubt, you can go through this document and we can understand. Okay.
Okay, no problem.
Okay guys, bye, take care.
Just take care.
Thank you.